Okay, welcome everyone to XPOSoft's quarterly webinar, and thanks for attending. Today we have a special guest. His name is, well, according to the slide here, his name is Dr. Jeremy. How do you pronounce your last name, Jeremy?
Rössler. it's a German name, so it's difficult. Germanized Rössler.
Can you explain the difference in the characters on your last name? Sometimes you have that B there, that kind of
that's a special German S character. It's I have actually two German special characters, which makes it extra interesting whenever I get to a airport or a hotel. And I need to find my reservation or my ticket or whatever.
Okay. All right, great. Well, today's XPOSoft quarterly webinar is AI-based test automation without AI. So it's great to have Dr. Jeremy here to share with us his thoughts on how to do AI-based test automation. And I ran into Jeremy several years ago, and he was giving a live demo, and somehow it didn't work, I remember. But he promises me that today he's got it going. And why don't we go on to the next slide, Jeremy, and we'll get this thing going here. So my name is Phil Liu, and I'm the founder and CEO of XPOSoft. We're a software testing company. It's all we do. We also do software QA consulting, and we have offices in SFO as well as in Beijing. Both locations very severely impacted by the virus. So we're all working at home for sure. So next slide, Jeremy.
Sure.
Yeah, just a few house rules. You can see we used to use GoToWebinar. Now we're using Zoom, and but it's pretty much the same. There's a chat window on the right-hand side, and you can enter your questions or chat right there. You will receive a recording after the webinar. So let's get right to it here. As I said, my name is Phil Liu, and when I'm not working, which is not too much, I travel around and do conferences, which is where I met Jeremy, and I also like to cycle. But it's really not about me today. It's about our guest speaker, and our guest speaker is Jeremy Rössler with the B and with the U, and I guess that's that pronounced a U with a O with the two dots on top.
It's a U.
Jeremy Rössler, and
right.
So Jeremy has a PhD, so we won't count that against him. I did meet him at an international conference. Where was it? A couple of years ago, Jeremy?
I think it was Ukraine. Yeah, it was.
Oh, geez.
Test X or something. Test X, test stage, something like that. Yeah.
Testing stage. Yeah, that's right. A long time ago. And Jeremy speaks at a lot of conferences. I think last time I saw you in Hungary, and you had said that you had done 30 or something like that?
Yes, I guess so, yeah.
Crazy. Okay. All right. Well, I'll turn it over to you, and you can tell us about how to do test automation without AI, with AI. Go ahead, Jeremy. Go ahead.
Great. Thanks a lot. So yeah, thanks for being here. Just if you're new to what AI actually is, I will give you a very brief introduction, just 2 minutes on what AI is and how it works, so that we're all on the same page here. I don't want to spend too much time on that. So if you think about a biological neuron, what you have in your brain, it's roughly, in its functionality, it's roughly comparable to a logical gate. So it's the smallest operator inside of your brain and inside of a computer, typically. And in the natural brain, you have a whole network of that. So you have like a couple billions of those things that make up your brain and your processing power. And you have the same thing in a computer. Whereas in a typical computer, it's the logical wiring is designed, is handcrafted by the designers of the chip or of the computer. And now the thing about AI is, with traditional programming, you usually give the computer the data and the software, the program, and the computer will then from that generate the output. Now, the interesting thing about machine learning or AI is that you give the computer the data and the output that you want to see, and the computer comes up with the programming by itself. So this is very interesting, and it's especially useful in situations where the programming would be very hard to do. Typical example that's easy to imagine is image processing, where you would have very hard time programming how to, for instance, how to recognize a dog inside the image. So this is typically what's done with machine learning. Now the question is, why would we use that for testing? Well, today 99% of companies face challenges in testing, according to Forrester research. And if you see the whole life cycle of the software, where the software is analyzed, planned, designed, developed, tested, and released, maintained, you see that the highest interest and the highest pain point right now, that's really the bottleneck of software development right now, is actually testing, as it is today. So for the release phase and the maintenance phase, we have advanced tool support. For the design, we have a lot of ideas how to streamline that and improve that. But the testing phase really is where today many companies have problems to get that straight and get that right. Now, obviously, testing, even or especially if you do it on a regular basis, if you test the same software again and again, then this becomes mind-numbing, and such repeated tasks are something that many people think are ideal for AI, which in a way they are. But testing is a very special beast. And if you think about it, there's a good reason to that, which is called the Oracle problem. Essentially, what it boils down to is, if you give an AI any software and ask it, find the bugs, then you ask for any given value, is this value correct? And if I would ask you as a human, is this value that is marked in the screen, is this value correct or not? You couldn't answer that, right? Because you don't know, is it, what kind of software is it? What kind of data went in? How is it configured? So you have no idea what that value in that context actually means. So you can't have no idea how on how to assess whether it's right or wrong. And frankly, AI is in the exact same situation. So it can't, for just a new software that it doesn't know anything about, it can't know whether this value is correct or not. This is called the Oracle problem, and it's one of the bigger problems. And one could even argue that if we could solve the Oracle problem for any given software, then we could solve any problem, because any problem can be transformed into an instance of the Oracle problem. So it's a really hard problem in general. Now, one could even argue, if you could solve the Oracle problem just for typical software, like we don't need to solve it for any given software, just for typical software, like, I don't know, your tax calculation program, your ERP system, your web shop, those things. What those software usually does is it transforms the solution as it's intended. The requirements are usually formalized via manually formalized into code, and the software, the AI then, or the Oracle, whatever, tests this formalization of the code. So the complexity of the underneath, the complexity of the software, the complexity of the problem that is being solved is hidden inside the software and is just formalized. And the AI then could be used to test that transformation. Well, the thing is, if you could, in order for the AI to be able to do that, it would have to understand the problem. It would have to understand the requirements in order to understand whether the code actually fulfills that requirements. If it could do that, then you could just use the AI to, instead of test the software, generate the software, and error-free. Error-free in terms of its understanding of the solution. This is very much comparable to a compiler. So today you can even prove mathematically whether a compiler is correct or not. It's still garbage in, garbage out though. So if you give it, a crappy program, a crappy source code, then the resulting program will also be crappy, obviously. So in that case, if you give it crappy description of the software that you want to have, then the resulting software will also be crappy. So in that situation, you would even still need the tester in order to test whether the generated software still is or fulfills the requirements that you have maybe not written down explicitly. So in that scenario, you would still need, even if you generate the software via AI, you would still need a tester. So this is one of the reasons that I say testers don't need to be worried about AI coming after them, because, rather the developers should be. Okay, so because of the Oracle problem, we can't directly test code or directly test software, use AI to test software. So what can we do? Well, we've been in a similar situation before. So when the steam engine was invented, the question was, how can you combine the steam engine with such a buggy to increase the mobility, right? So they had this very powerful new technology, very capable of doing things, and you wanted it applied to buggy to be able to move around much faster and be much more mobile than you were before. And if you think that AI can be applied to testing directly, it's like saying, okay, let's come up with a mechanical horse, right? So this obviously didn't happen, and it wouldn't have worked, because this is not the way that you can use the steam engine, and this is not the way that you can use the AI. So instead, you would have to need to adapt the technology and adapt the process. And this is also what happened in the past, right? So they invented the steam locomotive, the steam train, essentially. And with that, you have additional prerequisites, like a railway track. So you need to create those things in order to be able to apply this new technology to your problem. And building railway tracks was a huge effort, as you can imagine. And it cost a lot of money and a lot of time and a lot of human labor. But still, it was worthwhile, and it paid out in the long run, nonetheless. And in software development, we need to do the same. We need to find a way to apply that powerful technology that we have, AI, to our problem, which is testing. And as before, a mechanical horse is not the answer. So we can't just directly use AI and plug it into our system and say, okay, we want to replace the horse with this new powerful technology that we have. We have to change other things as well. So we have to adapt existing processes, existing approaches in order to make this work. And if you think one step further, actually, as I said before, using AI to test your software wouldn't even be the mechanical horse, it would be the Knight Rider, right? If you remember the now almost ancient movies or series from the 80s. So today we're closer than ever to that, but we are still not there. So we don't have a talking car that can drive alone, but we're almost there. And it took us like, 200 years to get there. So yeah, it's still a far way to go. So let's see, what can we do? So if we can't use AI to do the actual testing, maybe, especially in the realm of test automation, there are other tasks that we can use AI for. One, for instance, would be test maintenance, which often goes under the buzzword of auto-healing tests, meaning that one of the more annoying tasks of an automation engineer is that you execute a test and the test breaks because a button was moved or renamed or an ID changed or something. Maybe you could use AI to do that for us, to do the auto-healing of the tests. Another possibility would be to generate tests. So instead of manually writing our test automation, maybe we can have AI come up with those tests instead. Another possibility would be noise reduction in all varieties. Like when tests fail, we could rule out whether it was a bug in the testing or a bug in the software. When we have bug tickets created by users, we can reduce noise, all kinds of stuff there. Also, a typical or often a problem, depending on the scenario, is the availability of test data. So we can use AI to generate test data, maybe even anonymized for like user data instead of actual user data. And another possibility, looking ahead, on the road ahead, what might come in the future is defect analysis and even automatic fixing software. Actually, in very specific instances, Facebook is already doing that. So they have software within their development process that if their build fails, like if they have a red build because of a, say, compile error or a out of bounds error or a null pointer exception, something like that, then they even have AI today that generates a fix for that and automatically fixes the build. So maybe that's something we can look into. So let's go through that list one by one. First of all, test maintenance. Actually, it turns out we don't even need AI for that. We can have that today with just a different approach. We need a different approach anyways, as I said before, because like with the horse and the steam engine, we need to rethink our processes. And if we do that, turns out we don't even need AI for that. And I'll give you a demo just in a couple of seconds. The demo or the approach is based on golden master testing. So the idea that instead of writing individual assertions, you check and verify everything at once. So you, instead of writing an assertion that a specific text is present or a specific button has a specific color, whatever, instead of that, you just check everything at once. To do that, we use golden master testing. Golden master testing has been around since like the 80s or something, and it usually comes with two challenges. One is noise, and the other is redundancy. And we can address both of those. So let me give you a short demo of what I'm actually talking about. What you will see now is partly open source, so you can just go and use it. So this is a typical Selenium test. I'll just run it for you so you can see what it does. This test just opens a website, fills username, password, presses sign in, and therefore logs into the system. As you can see afterwards, it checks whether message success is being displayed on the website. So we have the website here. This is the underlying HTML. And if we now change just one character and run the test again, you can see that from a user perspective, the website now is clearly broken. So now the CSS doesn't load correctly, and this means that the website is broken for a user. However, the test only checks whether success is being displayed, so the test is still green, right? Now let's undo that and change something else, which is the ID. Now, as you can see, the test uses the ID to identify the element it wants to interact with. The ID, however, isn't rendered on the website. It's not being displayed. So for a user, there's no difference. So we change the ID, but for a user, this doesn't matter because the user doesn't see the ID. However, now the test fails. And this was a very simple test. You could obviously address some of those issues by using single page objects, stuff like that. But this is more or less the state of the art. And as you can see right now, the test fails when something as irrelevant as an invisible attribute changes, but it doesn't fail when something as important as the complete rendering, like the complete CSS changes. That's just not detected at all. So here we have, as I said, this is open source, so you can just go and download it. Actually, I can show you the very project. Let me show you. So this is the URL, recheck web example. So everything that you see here is just in this, repository. As you can see, it's the same test as it was before, just that we don't have the assertion at the end, and the driver, the Chrome driver, is wrapped inside the recheck driver, and that recheck project itself is also open source. So now we can execute that. Change that here. So now the CSS is essentially broken again, as you will be able to see. So now, as you can see, the website is broken from a user's perspective, but this time, in contrast to before, the test is actually able to realize that. So now it can say the background color changed, the border color changed, the text color changed, the position changed, the everything changed, and it can give me the concrete attributes, the CSS attributes that did change. So it's not that I have to look at the screenshot. I really get details about what changed. Let me undo that, and if I now change the ID or even delete it, and again, this is the same test as before, so it's using the ID to identify the element it wants to interact with. Now, if I execute that test, it can still correctly identify the elements and can still correctly execute the test and passes. And I want to show you how that works. So let's go back to the slides. Let's go back to the slides. So that was the demo. So the unbreakability, it's not actually unbreakable. There's still ways it can go wrong, but it works like for most typical change scenarios. So if you have a change, say by text, by ID, by XPath, by anything that you can usually have. And as you can see in this example, the sign in changed to login. And so it's not able to find the element by the text because the text changed. So the test, as you saw before, would now break. However, this is golden master testing. And golden master testing means essentially that we create a copy of the website and compare against that copy. So if the text has changed and we are not able to find the element on the new version of the website, we still have the golden master. We still have our copy of the website against which we compare. And in that copy, we're able to identify the element. So here in the old version, we can just make a one-on-one assignment of all the elements of the old version to the new version, which we have to do anyways because we want to show the changes to the user. So we have to do that anyways. And this time, using multitudes of identification criteria. So you can use the text, the type, the XPath, the CSS classes, the ID, whatever, to identify that change and that button still correctly. Even, it's even one step further because not only do we have the information about that button, we have the information about the complete website, and we make a one-on-one assignment, meaning that even if that changed completely, like everything changed about that button, the position, the color, the ID, the name, the text, the XPath, everything, still, if it's the only change, we can still identify it correctly. Because if it's the only change, we make that one-on-one assignment. We have an element that vanished here, have an element that appeared here. So we can more or less safely assume that it's the same element, right? So the test doesn't break and can continue to execute. And we just log that change. We can even go one step further. So we can, instead of, now we have the problem if we maintain the golden master, if we update the golden master with that change, then the test will break. So in a way, we only postponed the breakage of the test, right? But we can go one step further. So when we create the copy of the website, we can now, oh, sorry, there's the video that doesn't play. Oh, what's now happening?
So I guess rather than asserting or checking the correctness of something, you're just really checking for or noting differences rather than
Right,
correctness.
right. So the idea is instead, so in a way, what we do is more like a version control of the UI rather than asserting correctness. So we just highlight differences, and you can then go and approve those differences, reject those differences, or ignore those differences like you would do with a version control system with your git ignore file.
Mm-hmm.
So I hope now that video plays. For some reason it doesn't. Okay, as you can see my...
You must not have checked the differences.
Yeah. So you see? Okay, what I wanted to show here is if the video would play, you would see that what we do is when we create the copy of the website, we insert additional attributes into the copy of the website. And because those attributes are inserted and are not on the actual website, they can never be changed by any change on the actual website. So they can't be affected by change. We call them virtual constant identifiers. And this is what you can use also to reference your elements. And this also helps, and this also helps with problems like these, where you don't have good identifiers. Like if you don't have an ID or something and you would have to use such a XPath or CSS XPath expression, instead you can use also that virtual identifier. But as you said before, this is essentially not asserting for correctness. This is highlighting changes. So what we do is we call this internally Git for the GUI, because this is what it does. It shows you the differences. And as I said before, there are essentially two problems to that, to golden master testing, and one is noise. And with Git, you would have the same problem. But for that, to address that, you have the git ignore file. So in your git ignore file, you can ignore the logs files, the class files, everything in your target folder, and everything else that is created during your build. And if you imagine you wouldn't have that, like if you would delete the git ignore file, it would be very annoying, because all the time, all those temporary files would show up as changes, right? And the same thing is true also for this approach. So what we did is we kind of recreated that, and we now have the recheck ignore file. You get the similarity here. And you can now ignore attributes, elements, parts of the DOM in order to be able to ignore things that are irrelevant to you. And I just want to give you another demo to show you how powerful that is. So these, as you can see, these are two websites that are very different from one another. So they differ in color, in font, in positioning, in a lot of things. And if you compare those, obviously you will see that kind of everything changed as expected. But now, since we have this this filter mechanism, you now can use semantic filtering to pinpoint the changes that you're interested in. So you can say, for instance, ignore everything positioning, like the XY coordinates, width, height, margin, padding, stuff like that. Then you can say ignore everything style, like the color, the background color, the font, and so on. And you can say ignore, by the way, these are predefined, so you can define your own however you want, but there are some predefined filters. So you can say ignore, for instance, invisible attributes, invisible changes, like ID, XPath, everything like that. And as you can see, it will just highlight the differences in content. Like here, the actual value of that cell changed, as you can see. So this is a very powerful mechanism. that allows you to ignore everything that you're not interested in. And it goes even further. So as you can see here, you can even, with our example that we had before, let me just open that. I can now say, okay, I have this change. And as you can see, this change is green right now. Reason being that I defined in my recheck ignore file that I wanted green. So this is also the reason why the test passed. So usually, so when I execute the test now again with a changed ID, it will still correctly execute. So it won't break, the test won't break, but it will highlight that difference as, you know, as you can see, as being relevant for you.
So would
now,
you say that this helps with the noise problem, I guess?
Yes. So this helps with the noise problem. So you can now ignore, like if you have random IDs being generated, you have a date, a username, like everything that changes frequently that you are not interested in as a test creator or test maintainer, you can now just ignore that by creating such a filter file. You can have your own, as you can see, and just ignore that change. And it goes even further. So now you can, if you accept the change and apply the change to the golden master, we can now detect that this is relevant in your test, and we can now even update the test. So as you can see, we now changed the Java file. So it just reloaded, and now it's got the new ID that I used. And all of that without AI. So this is just a different approach to the same problem using golden master testing and using those techniques that I explained before. And leveraging these, you can now, without AI, have rule-based deterministic ignore. All of that is open source, by the way. You can use it offline. You get Unbreakable Selenium with auto-healing tests. And in theory, it works for any technical interface. So we have a working implementation, as you saw, for web. We have a piece of proof of concept implementations for PDF and XML and JSON. And you can essentially go and implement it for any technical interface that you have to interfere with. So now we, as I said, we solved the problem, kind of solved the problem with test maintenance and auto healing, and we didn't even use AI for that. So the next point on the list is test generation. Let's see what we can do with test generation. Most people think that testing is easy because they just have this image in their head where you have a tester, manual tester, and a software. And all the complexity of the software or all the complexity of the problem is hidden inside the software. And in an ideal world, you have an easy to use, nicely created UI UX interface, UI user interface, where all the complexity of the underlying problem, like the text calculation or the I don't know, the ERP software, whatever it does, is hidden inside the software, and the tester has to do very simple actions like component recognition. It has to find what is a button, what is a text field. It has to, you know, enter some text at some point, click a button maybe, and has to do very minor data test data management. And this is the view that many people have on software testing, and this is also the reason why many people kind of look down on software testers. And as I said before, this is the wrong view, because what is missing in this picture is a verification step, right? So this is just the execution step.
Are you saying you look down on me?
No, I actually don't. I was saying that software testing will live longer than software development. Remember? But I know software developers who do that, and I despise the fact, but I realize where it comes from, and this is where it comes from. So if you neglect the verification process, if you just focus on the test execution, then this is the image that you have in your head. And this is also the part where AI can help you with, right? With the test execution. So you can, in that instance, you can replace the tester with an AI and have the AI execute your software. I wouldn't call it testing because it doesn't include the verification. So it doesn't include asserting correctness. It just executes the software. And this is a video. Hopefully that works. Right, this one works. So as you can see, we are now testing a web shop here. And this is now AI execute, or kind of random-based executing the software. And as you can see, the first thing it does, the very first thing, is trying to order something from the web shop, which is like the main use case of a web shop, right? And this is done with a general purpose AI. So this AI was not trained specifically for a web shop or for e-commerce. It was trained on something else. But what we get out of this when we generate tests is actual tests. So we get code. This code can be incorporated in your CI/CD and can be executed every night or every commit or every merge or whatever in order to verify that the software still works as expected. The overall process then is that the user or tester tests the software, and while doing so trains the AI if there are some specifics to the software. I'll get to that in a minute. And the AI automates the software, and then the user, if a difference comes up, then the difference report, as you just saw, is being generated, and the user can use the tool in order to verify the difference and even maintain the tests. But the important point here is that you don't need AI for the actual test execution. You just need AI for the test generation. So what we did here, the problem with AI, with neural networks, as I was introducing them earlier, is that you need a lot of test data. So you need like thousands or even hundreds of thousands of training data in order to be able to train the neural network correctly. And this is prohibitive for many projects, like for many smaller. If you're at Google or Microsoft, this is probably not what you can do. The data that you have in your hands in order to generate a test. So what we did instead is we trained a neural network how a typical user uses a typical software. So this is then not for one specific software, but like general purpose, like any project can leverage that neural network. And what we learned in turn is that what the AI learned from the test data is essentially UI, UX design principles. So if you visualize that, it looks like that. So this is the rating. Like if you give an AI this, or our AI in that case, this screen, this web shop, and say, okay, click on any element that you want, the AI would go and have a look and say, okay, this one is small, it's off, it's not in the center of the screen, and it's the color is not very different. And this one is very big, very much in the center of the screen. The color is very intense, is much more intensive. So the AI would go and click on this, and this is what you saw in the video, right? And then on the next screen, it would do the same, and it would rank all the UI elements and would say, okay, this add to cart, this is the main user scenario that I want to focus on, because this is in the center of the screen. It has the next, according to the ranking, to what I learned from existing test scenarios, this is where I want to click, because this is the color is different, it's highlighted in the center of the screen, it's stuff like that. And then you go to the next screen and the same applies. So you see, okay, this one is more interesting than this one. And the UI would click, and as you can see, the X button is even rated even lower. So the UI would go and say, okay, I need to click here. And this is actually what we learned, what the AI took from being trained with a lot of different tests or usage scenarios, is that it learned how UI UX works. Now what we did is we did reverse engineering. So we had a look at what what attribute, the AI pays attention to, like the size of the button, the color of the button, the positioning of the button relative to the overall screen, and also in relation to the last action, the tap order, the all those things. And we learned from our trained AI, we learned what the AI does and what the AI pays attention to, and then we reverse engineered that. And the reason why we did that is it's easier to fix glitches, because sometimes the AI does things that just don't make sense, but you can't ask it. You can't say, the AI is a black box. You can't go and say, oh, why did you do that? Or why does it make sense to, push that button instead of the other one? And also it's not explainable. Like if you have a decision, you can't go in and debug it. You can't go and say, oh, I want to change that behavior, but first I want to understand why the behavior is even there. So with an AI, that's very difficult to do. And also another thing we did, which I will come to in a second, is UI UX rating. And we didn't want to have a self-fulfilling prophecy in the sense that the AI generates the test that it later rates. So I'll get to that in a second. And also another problem is that you have noise, because sometimes companies intentionally screw with a UI UX design in order to nudge users into doing what they want. Like if you have a check-in process at an airline, you usually can add additional insurance or additional baggage, or have some sort of upgrade, and the companies use specific UI UX design elements or design things in order to nudge users into doing that. And we didn't want the AI to pick up on those, although it would, like very much comparable like with Amazon being able, or when they introduced the AI in order to rate applications to their jobs, the AI would pick up that men should be preferred over women, which is something that you don't want. But you can't easily fix that inside the AI, right? So you can't go in there and say, don't do that.
Yeah, so Jeremy, so would you say that you develop several types of heuristics, and then in order to reverse engineer them, you have to have some exceptions to those heuristics? Is that right?
I would say that if you just use the AI and give it the raw data and train it on the raw data,
Yeah.
At some points the AI can get confused, and also the AI is missing some things. Like the AI, the way we trained it wasn't able to pick up on semantic clues. Like if there was a button where you would have to pay a premium, then most users wouldn't click that button, but the AI would click the button, because that UI UX for that button would probably have a higher rating than for the other one where you wouldn't pay a premium.
Right.
So
yeah. So we have a question that came in from the audience from Jim. And this is not really related to software testing, but related to AI. And since you're a PhD, I figured you could answer it. But he says that, are there any thoughts on using this in the pharma industry for drug testing and development of drugs? Because they get tons of data, in terms of, I guess, if it works or doesn't work, as well as the symptoms and so on. And what are your thoughts on that, using this type of approach for the pharma industry?
So I think there's a lot of potential in there, and I think I don't recall names from the top of my head, but I'm pretty sure there are companies and startups already working on that, where they use AI in order to leverage knowledge that is hidden inside the data in order to speed up processes and speed up, for instance, drug development and stuff. So I'm very sure that there is something going on there, and I've seen news, and being an entrepreneur and being an AI nerd, I have some newsletters regarding that. So I read that there are companies doing that, but I'd have to do a research in order to come up with the names of those companies. But yeah, this is essentially one of the things that AI can help you with.
Right.
But again, it's not a silver bullet, so you can't say, AI, please go and develop the drug. You can just kind of, at some point, speed up the process and speed up some aspects of it. Hopefully that answers the question. If there are more questions, I'm very happy to answer anytime. Okay. So what we did here is essentially after learning what the AI did and after learning from the AI, we reverse engineered that and removed the AI. And now we're even able to do a couple of things. First, we are able to give a website a rating on their UI design based on what we learned from the AI, what the AI learned from the data. So if we have a website, we can just say, okay, there's a certain probability the user will click here, but a much higher probability user will click here. Again, without semantics, just on the UI/UX. And we can give also a certain rating on how to improve the website, and we can give a rating compared to competitors in the field. Like we can have a rating between e-commerce websites and say, okay, this e-commerce website should fare better only based on its UI/UX design and the main usage scenarios that we maybe recorded using Selenium IDE, or that we have written down as test cases. These main usage scenarios get a specific UI/UX design, UI/UX rating based on how the elements are put on the screen. So this is what we did in order to have test automation without AI. But we can still have it in there. So we now have the option kind of to switch it on or off, depending on the scenario that we want to go for. So we can have a UI/UX design with or without AI based on usage data, for instance, on Google Analytics, something that we're working on. You can generate realistic tests according to how your users use your website with or without AI. You can have visual testing, as you saw before, without AI, and functional testing because we don't need it for that. And you can auto-heal your tests without AI. And then usually one of the questions I get is, how do you know how many tests you need to generate, or how does the AI know when it's got a good, what scenarios it should go for? And what we do there is we generate a state graph. So we generate an understanding of how the website works in order, you click on that, then you're on an article site, then you click on order, then you're on the order site, then you click on account, then you're on the account part of the website, stuff like that. And then we try to generate as many different usage scenarios for as many different parts of the website or parts of the functionality that we see in order to cover as much as we can. And but also reduce redundancy. So we don't want, it doesn't matter which article you order, it's still an order process, for instance. So we don't want to have 15 tests that order different articles. We probably just want one or two with different scenarios. So we use the state graph in order to optimize that coverage of test cases. So that's essentially already it. Now, Are there more questions? I mean, there's already been one with a AI and drug development, pharma industry. Now, are there any more questions?
I don't see any other questions coming in, Jeremy. I really appreciate your time in showing us retest. I was wondering if you could comment on, it seemed like your tool also does evaluation of websites, whether they're good or bad, evaluating their design. And is that kind of like a new business for you?
That's actually something we're working on right now. So this has come up in the recent couple of weeks. We didn't do that before, but it's kind of a side effect, a side thing that just the data we have and the AI we have gives us the possibility to do that, and we just ventured into that.
Right.
That functionality and trying to explore that right now. So it's very fresh and very new for us. Very exciting also.
Yeah, that's very exciting. And so for your usage of AI, you actually use it a little bit and then you throw it away because you get those rules and heuristics, and then you reverse engineer it and go off on your own and kind of throw away the AI. Did I kind of get that right?
Yeah, in a way, you're right.
Okay, well that's good. I mean, AI still has a usage. It's not like, it's no good. I mean, it's a good way to get a head start, right? And to understand.
Yeah.
Yeah. Okay, folks. Well, that is the end of today's quarterly webinar for the second quarter. And thanks for attending. As I said before, we will have the recording posted. And so stay tuned for our webinar next quarter. Jeremy has some sources of his images there. And anyways, so thanks a lot, Jeremy. And we'll be talking to you soon. And I hope to see you at a conference one of these days if we can get back to whatever normal may or may not be.
Yeah, right. Hopefully at some point. So thanks for having me. Thanks for having the time. And if anybody wants to check out Recheck Web, here's the URL. And we'd be happy to get some more GitHub stars on that. So thank you very much.
Really good stuff, Jeremy. Thank you again.
Thank you.
All right.
Bye.
Bye.